Good morning, my YouTube viewers. Crystal here. I wanted to make you another video on the digit recognizer competition with Kaggle. And the reason why is because I did give you solutions from other people. This one solution from someone, he had a score of 99.482. And yesterday I started working on a submission from another person, and he said that he had a score of 99.5, but I just couldn't stay up long enough. This particular algorithm had 100 epochs, and there was no way I could stay up for 100 epochs. And the way Kaggle works is if you don't do anything for like 15 minutes, they'll send you a message and say, are you still there? So you have to sit in front of the computer and watch the computer and make sure that you're still doing something, and then you can respond to Kaggle's questions, because if you're not doing anything, Kaggle will just shut you off. So I just thought about it last night, and even though the outcome was 99.5%, I thought, well, there's not any way I can stay up long enough to do this. I can't stay up long enough to do 100 epochs. And this last score here, this sequential score here, it was somebody else's algorithm. It was 99.482. They had like 30 epochs, and so it took about an hour to run the program to make sure that it worked, and then it took another hour to actually save the program, save and run the program so I could submit it to Kaggle, and sometimes, like when you're just starting out, you don't want to sit there for an hour. And I know, like me, I get really impatient, and that's one of the reasons why I'm not so keen on taking the courses, because I feel like I should be working on problems. And me personally, I learn best by doing things. I don't learn of massive amounts by taking a course. I learn by working on problems. And so that's why I would rather work on the problems. But I am in the middle of an Analytics Vid Higher course on neural networks. But again, I stopped in the middle of that to work on problems because that's what I felt I should be doing. So what I did was I wanted to show you something. I have just recently submitted this algorithm, and I got a score of 98.625%, which is quite respectable, and it only worked on 10 epochs. So that was good. It only had 10 epochs. And so you didn't have to sit there and wait an hour for it to go through 30 epochs, or wait a day for it to go through 100 epochs. You could do it relatively quickly and see the results. And for a person just starting out, that's what they want to see. They want to see the results. So what I wanted to do is I wanted to go through this code with you. And what I'll do is I'll go ahead and make it public. So if anybody wants to look at it, they can. So basically what I did was I got the algorithm from this site right here. So it was a tutorial. But if you look at the tutorial, they used I think it was the MNIST package. But there is an MNIST package that comes with Keras, and it has 70,000 images in it. But you have to break it down yourself, and it does it a little bit different way. And one thing that I learned while studying this Keras is that, you can have 3 or 4 dimensional arrays. So Keras is quite complex. So the first thing I did was I updated all of the files that I thought I would need to work on this problem. And then I updated the Keras files. I imported the files from Kaggle. So the files from Kaggle are different from the MNIST files, because if you go to Keras actually has the MNIST file in it. But rather than breaking it down into a train file and a test file, they just have one file of 70,000 characters, and you have to break it down the way you see fit. And because the files, the MNIST files, are different from the Kaggle files, you have to deal with them differently. The way that you deal with these files is different. So really all I did was I didn't take the entire program. I just took the little algorithm that I needed and put it into this program. But I still have to give credit to that tutorial, because it's not my own work, it's somebody else's work, because I'm just learning. And that's another thing, is I was watching a video by Ken G, and he's a data scientist, and he even says that you have to look at the work of other people to learn it. Is the only way you're going to learn it is to look at the work of other people. So it's not really plagiarism. If you're trying to learn something, you have to look at other people's work to learn it. And it's just like being a writer. This was like 40 years ago, close to. I took a course in English or writing or something like that with the University of Maryland. And that's what the teacher said. He said that if you want to become a good writer, you have to read a lot. He said you have to read all the time if you want to be a good writer. And that's one of the things that I fall short, because I used to read a lot, but then my eyesight deteriorated. And because my eyesight has deteriorated, I don't read that much. I just read what I need to read. And mostly everything I read on the internet. I don't even buy books anymore because, I need to wear glasses. And so it's a bit of a pain to have to read and wear glasses and things. So my reading is mainly professional. And because also, like when I'm working, I have to wear varifocals. So that makes it even that more difficult. So I don't read that much anymore either. So I guess that means I'm not going to be a good writer. And I only read professional literature. But I do look at algorithms. So we have read this, we've read the 3 files, the train file, the test file, and the sample submission. But I like to see what they look like. I like to call them up and see what they look like. So you'll see the train file has 784 columns for the 784 pixels. And that's also, I believe it's 28 by 28. Let me just look and see on my, little, my little 28 by 28 equals, I'm just looking right now, 784, 28 by 28 is 784. So you've got 784 columns, which is your 784 pixels. And these pixels are in binary data. So it's going to be like either a 1 or a 0. And you've got a label, and the label tells you what the number is. And then so we've got information on the train file that tells you it's 785 entries. That's your 784 pixels plus your 1 label. And we look at the test file. The test file has 784 columns and no label. So the columns are the pixels. That's 28 by 28 pixels. And there is no label, because what you have to do is you have to determine what the actual number is. And this is a sample sub. This is the sub that, Kaggle is saying that they want the file to be submitted in this format. So you have to have an image ID and a label. And you'll notice that there is no image ID. So you have to create an image ID. And there's various ways that you can create an image ID. I mean, what I personally would have done was I would have done test.index+1, but I believe that this algorithm, they used a different method. But the easiest way to do it is text.index+1 if you want to make your own image ID. So what we did was we set up our train Y and our train X values. So train Y is your train label. So that's your target destination. And your train X is your train drop label. And train is everything else except the label. So I wanted to see the shape of train Y, and it's 42,000 entries. So it's just an array. And here's the little diagram to see the breakdown of the numbers. It tells you how many of each number was sampled. Okay, so basically what you had to do was you had to categorize train Y, and I wanted to see the shape of train Y. And so whereas over here in the beginning the shape was just an array, just a one-dimensional array, now train Y is 42,000 by 10 columns, and that's what happened when they categorized it. So train X equals train X values reshape, and it's the length of train X by 28 by 28 -1, and test was reshaped in the same format. And so I wanted to look at the shape of train X and test, and now train X is now a 4-dimensional array, and test is now a 4-dimensional array. And so now we're working up in the higher dimensions to get the information that we need, which is the thing about TensorFlow and Keras, where they have the ability to work in higher dimensions, whereas NumPy and Pandas don't. So I wanted to see how many dimensions was in train X and test, and each column had 4. Train X had 4 dimensions and test had 4 dimensions. So now what we do is we create our model. We set our model equals sequential. We set up our image rows and image columns were 28 by 28. So we've set up like a table with 28 values, 28 rows by 28 columns to give you 784. And so now what we're doing is we're getting into the actual Keras model, and I am in the middle of taking a course on neural networks, and they explain to you how that you do it. But this is the code just to add certain dimensions, certain characteristics to the models, and the shape is going to be 28 by 28, which means it's going to be a square. We did some more work to the models, and this is just more programming to deal with the models, because you have to do a lot of work to the data just to get an output, because what Keras does, or what neural networks does, is you have an input, and then you have a bunch of hidden fields, and then you have an output. So this is just adding to the model, and that's one of the hidden fields. So we add another layer to the model, and we use the dropout function, and we flatten the model. And then so what we do is we set the model up, and we go into our hidden layers that do all the work. We compile and train the model. And so now we actually fit the model. So your batch size is going to be 128 and your epochs is going to be 10. And this right here, this was some code that I got from the original algorithm, but the code didn't work on Kaggle. It works if you did it on Google Colab and you were using the MNIST file from Google Colab, but it didn't work on Kaggle. So what I did was I just made it remarks. So if you were on Google Colab and using the algorithm or the program on Google Colab, it would work because you would be using the MNIST file from Keras, and that file is different from the files in Kaggle. So you can't use that code in Kaggle, and I should have deleted it, but I didn't. So now we've got our 10 epochs. So it took a while for the 10 epochs to cycle through, but it definitely didn't take as long as the 30 epochs in the previous video that I made you, and the 100 epochs and in the algorithm that I was working on last night, that I just thought there's no way I can stay up for this. So this is your 10 epochs, and it doesn't give you as high in accuracy. You don't get as high in accuracy as you did on the 30 epochs or the 1 epochs or the 100 epochs, but it's certainly manageable. And if you're just learning how to do Keras, then you have to sacrifice the accuracy for a shorter amount of time so you can learn how to use the Keras, because obviously I'm learning how to use Keras because with the Kaggle competitions you have to know how to do deep learning to do a lot of these Kaggle competitions, which is what I want to do, is enter these competitions. So for the time being, I'm sacrificing accuracy for a shorter amount of processing time. And then so now what we're doing is we're testing on our test file, and you can see YPRED is an array, and it gives you all the information in that array. So they set up YPRED and an MP array. So now you see YPRED again. And this is some more processing to where this is your YPRED final. And so what they do is when they cycle through it, they take every number and they append it to the file. And this is your results, this PD series, while YPRED final, and they're going to give it a name called label. And then so we set up our submission file of PD series range 1 to 28,001, name equals image ID. So that's how they set up the image ID, and results are the results right here. So, but they didn't have to do that. They decided to set it up that way, but they didn't have to do that. They could just as easily done test.index plus 1. And you'll notice here this says range 2001, 1 to 2001. So the way I would have done it would have been more simple, but that's how they wanted to do it. And they submitted a file into digit.mnist.csv, and I always want to see the submission file just to look at it before I run it and save it, because I want to make sure that it's working, which is what happened a few days ago. I looked at it, and then over here at the bottom it said NAN, and I thought, oh no, is it going to run? Is it going to run? So I went ahead and ran it, and of course it didn't work. Of course it went into error. So it's very complicated, and that's another problem that we have is we have a lot of people going on to Kaggle and they're submitting notebooks that don't work. And you have to ask yourself, why would you submit a notebook that doesn't work? That's unusual, but a lot of people do that. And that's why I've made this notebook public, because I know that this notebook does work. I submitted it and it worked. And so it's always a good idea when you're looking at notebooks to check and see if they've actually been submitted and they actually work, because there's so many people that put their notebooks that don't work on Kaggle. And why would they do something like that? Why would they put an unworkable notebook on Kaggle? But that's exactly what they do. So this is the completion of the code review, and you got a workable solution to this recognize the digit using Keras TensorFlow. And if you like my video, please like, subscribe, and share. And you can let me know what you think of my video. And if you like the work I do, I've got my email address down below for donations. And the reason why is because I don't have enough subscribers to monetize. And the only way I can make money on my videos is to ask for donations. So thank you so much for watching this video, and I look forward to making the next one for you.